Well, good morning, everyone. We'll go ahead and get started. We are officially live on Facebook, and the link has been shared to our LinkedIn and Twitter pages. So wherever you're joining from, thank you so much for joining today's webinar. And the topic today is going to be on a series that we have running on why you should be a tech company and focusing on data science and advanced analytics. So just to give everyone a heads up on what Blueprint is, maybe you've never heard of us before and you joined because a friend asked you to, or you found us on LinkedIn as a referral on a webinar page. Blueprint is a technology solutions company. So anything from strategy to implementation, delivery, execution, we do it all. So whether it's running managed services or making sure that we give you everything you need to succeed in running your own services, we do a little bit of everything. So we love partnering with companies of all different industries, and we want to share just a couple of things that have really, that we have been able to see in the data science and analytics side, and hopefully these insights will be beneficial to you and your company moving forward. So just a couple of housekeeping tips. If you have any questions at all, we'd love to answer them. Cori's going to be answering them live, and so you can just add them to the Q&A section, and we'll make sure to answer all of the questions toward the end of the session. So if you have anything, make sure you add it on there. And I've also added in a link on the chat, and this is a blog post that Cori wrote, and we just published it recently this week. So if you have some time after this, and you want to check it out, be sure to just click on that and you'll be directed to that page. But without further ado, Cori, I'll hand it over to you if you can just give us a quick intro about yourself and then hop right into the presentation.
Yeah, sure. Thanks for the segue there, and hope I get tons of views and likes on my cool page. But really, if you're interested in data science, it's kind of a small scope but pretty detailed post. So have a fun read. So I guess a little intro of me before I get started. Let me go ahead and click this button. Make sure I'm using Zoom properly. Okay. Well, that's a little. Might have a little technical issue. Probably should have tested this one first. Let's go with. Sorry, give me 1 second while I do this. Looking for system preferences. Zoom is allowed to look at my screen. And I need to rejoin. So quit now, be right back.
Okay, no problem. Well, while we're waiting for that technical issue to be sorted out, you guys should definitely go and check out the blog post. So sorry about that technical difficulty, but we will be back in just a minute.
All right, let's give this another shot. Perfect. Okay, so hopefully we can see now. We're good?
That's perfect.
All right. So yeah, I guess quick, who am I, and intro before we get going. So I'm data science by trade, like most data scientists these days. I've started an academic background, so I've got publications in computational fluid dynamics, optimal control theory. I've solved a bunch of problems across various industries. From there, I also did some teaching, university math and physics, like a lot of us academic background people did, and decided, hey, this is neat, but what about industry? So I jumped ship, started checking out industry, and for the past number of years now, I've been leading data science teams, building data science products across multiple industries, just putting data science to work and to get some value for people. So today, we're, like Ruthie said, we're going to talk about you should be a tech company, the data science and advanced analytics perspective here, right? So we've got a whole series of these, definitely check them out. But what we're going to look at today is why you should leverage data science, and we're going to get a little bit into how to do this successfully, right? So to have this talk, we're going to go through a couple sections. First, what is data science? It's important to know what we're talking about before we start talking about how to do it. And then, why invest? Is there data to back this up, right? I'm a data scientist. That tends to be how I think about problems. And is there data to say, yes, you should invest in data science? Quick preview, yeah, spoiler, there is. We'll get into it though. And then from there, we'll talk a bit about how you can do this yourself, right? So whether you're a data scientist yourself looking to join companies, looking to break into the data science field, right? It's really important to know if you're dealing with a company and where are they in the process and what's the most valuable skill set to them, right? So if you're a data scientist or breaking into the data science field or a business yourself, we'll get into, what are the skills you need to look for. So let's just start with the easy talk, right? What is data science? Now, there's a million blog posts out there on the internet today, and data science has been pretty buzzy and trendy for about a decade now. And everyone's going to tell you, I know what data science is, listen to me. And you can do a quick Google search for data science Venn diagram, and you'll see something like this, right? There's thousands of different Venn diagrams, all saying slightly different things, similar ways. Everything from really simple ones like 3 parts, very few words, to really complex, cool looking structures like this. And at the end of the day, they all kind of answer the question, but no one really knows better than anyone else. Data science is super broad and very gray around the edges. So what is it? A Venn diagram is difficult to just pin down a single one. I will say, I'm human, I've got an opinion. I'd pick the simplest ones. A big part of data science is being able to explain things, right? And if you put a giant, huge diagram in front of somebody to try to explain the details and the intricacies, you're going to lose some people. So I'd say keep it simple, right? There's code, there's math, and then there's some problem you're solving, right? So, again, as a data scientist, when, data science definition changes through time. So let's take a look at what is data science today. If I type in data science in Google image search, let's just go ahead and scrape the first top 20 results, toss them into a word cloud by term frequencies and see, when people talk about data science today, what are they talking about? So a couple interesting ones to point out here. Scientist, 100% agree with that one, right? Data science, scientist, but right, it makes sense, right? Data scientist is someone who's forming hypotheses, running tests, collecting data, iterating. So I love that one. So other big ones in here, machine learning. Machine learning is very buzzy lately, so I could totally see that. To be honest though, there's a lot of data science out there that is not machine learning, and that's okay, right? There's a lot of good value to be had without bringing in machine learning as the tool. But on the other side, yes, machine learning is an expected and required skill set of data scientists, and it does bring a lot of value. So that's good to see there. Business, I'd say, is critical. Can't be a data scientist without really knowing the business and working closely with the business. So I'm happy to see that one be so big. A fun one, I'm sure I'm preaching to the choir here a little bit, but as things get buzzy, markets stand up around them, and you can see course and career and some other similar things. So yeah, if you Google data science, you're going to see a lot of people talking about how to become data scientists, and they'll sell you their course or their book or how to have a successful career. So yeah, those are big these days. And that's interesting to see reflected here. Anyway, wrapping this one up, right? Algorithms, statistics, models. Okay, it's good to see at least the basics are covered there. So, okay, these are weird ways of defining it. Let's just, in passing, let's look at the Gartner glossary. What do they think? So we'll just read this real quick. So the data scientist role is critical for organizations looking to extract insights from information assets for big data initiatives, and requires a broad combination of skills that may be fulfilled better as a team. So first thing I see here is, I don't agree, right? Big data is a skill set data scientists are expected to have for good reason, and they work with big data. Not all data science initiatives require big data, right? There are plenty of great use cases that you can use small data and still have successful machine learning models, solving problems for real world people and getting value. To paraphrase Andrew Ng himself, right? The man, the myth, the legend. Big data is not necessary, nor is it the only thing data science can do. right? But I will say this underlying part, a data science team is definitely much better at covering the broad set of skills required for success here. It's pretty unrealistic to think you'll find, if you're at the, either entering the industry yourself or a company looking to invest in data science for your first team members, you're not going to find somebody who can do it all. There's too much there. It would take a lifetime of expertise to grab, you know, a few of these pillars alone. Definitely not all of it. So anyway, I hope that wraps up. What are we talking about here? Data science, right? And my favorite definition, most simple one, right? It's code, some math, and some domain knowledge. Okay, so why invest in data science? So again, from the data science perspective, if I'm going to make a decision on should I invest in data science, I want to see, is there data to back that up, right? And the answer is yes, there is. There have been a bunch of studies into this already. And I'm showing some results here. This is a meta study from Mackenzie where they basically just looked at a whole bunch of data science initiatives a few years ago and how successful were they, right? Data science and AI. So let's look first at this stacked bar. What we've done, or what they've done, is they've broken down all the use cases of analytics in various industries. And they said, okay, let's break it into good for AI, not good, or kind of good, right? And we see this top one, 15%. This is saying 15% of the problems being solved in industry today, you don't need AI. You don't need advanced techniques to tackle them. They're good enough as is. You can throw a bunch of resources at it, but you're not going to get much ROI there. Okay, that's 15%. 16% though are problems where you kind of need AI, right? The traditional techniques are not going to get you the result you need to really drive decision making. So this is, you know, they call it the green field. This is where machine learning engineers and experts really love to thrive, is these new problems we can solve. But what I love to see here is, and to really focus on, is 69% of all the problems out there that people are trying to solve today, you can solve better with machine learning, right? Or data science techniques, whatever it might be. And this is a huge chunk, right? This really tells you that not only can data science help, but for most problems, it can help, right? And what they do here is they've broken down this 70% chunk into different industries. And it kind of gives you a good estimate of your ROI here. What's the incremental value percent by industry you could expect by trying to level up your 70% here? So you see things like travel has got giant returns, retail, 87% is huge, transport logistics, if you're in supply chain, right, 89%. So there's a lot of value on the table for most industries. And the key comes to really the low-hanging fruit, right? You have a process, it's well-defined, someone's solving it with old school techniques, and we just want to level that up. So it's a pretty low-hanging fruit problem for data scientists. So just a quick example. So we've talked a lot abstract, high level, but just a simple example with some numbers, right? Think of retail. The industry average accuracy for retail forecasting techniques, if you're using traditional tools, is about 68%. It's not bad, but it's enough to get the job done, but it's not great, right? What's great to hear from a data science perspective is a modest increase to that accuracy by 10 to 20% will have huge ROI for you. So the numbers to quote here are averages, of course, but 5% reduced inventory cost and 2 to 3% increase in revenue. Now, okay, you're probably asking, how do you get 10 to 20% increase in accuracy? It seems like a lot, but the reality is this is one of these low-hanging fruit pieces, forecasts. For a data scientist, it's basically, think of it as going from a standard tools like ARIMA models and just bringing in some external features, right? If you bring in something like holiday calendars and promo calendars, your accuracy on your forecast is going to get this 10 to 20% from that alone. So it's really low-hanging fruit for someone with a data science skill set to come in and work with a team and level something like this up. So that's one example, right? Just from a bunch of average data, but you know, Blueprint does a bunch of data science too. So we've seen some of these mini use cases, and I'm not going to bother trying to list all of them, right? The field is gigantic, but we can talk about a few recent wins we've had that have, you know, really tell the same story, right? So we worked with a major retailer to beef up their forecasting exactly the same way we were talking about there, right? where it's a relatively low-hanging fruit task. You bring in some additional data to improve your models, and bam, better forecasts. And what you do from here, right, there's a lot of directions you could go, but we took this in the inventory management direction next, right? Once you have a better forecast, you can also use data science to optimize things like supply chain, or how much inventory do you hold on the shelf, because it's definitely a balance game there. But 2 big wins for a major retailer. Another example, just get retail out of your minds. All industries are on the table here, right? So global tech company, and they have a ticketing system. Think of like Zendesk or something, where you enter a support ticket and ask somebody for help. We used NLP tools to extract information and classify things from these tickets to help people understand this is a high priority ticket someone needs to be alerted of soon, right? Instead of just entering into the backlog with the other thousands of tickets. Right. And then, another thing we did for them, given a ticket, you think of managing a team of people working tickets. It's very difficult to staff your team looking forward into the future, right? Another planning thing, just like forecasting, without knowing about how much work you have to be done, right? So we also used NLP techniques and a couple other features as well to be able to train a regression model to say, okay, this ticket should take somebody about this long to resolve, right? So this really helps you make your plan on, who should be working on Friday, right? Do I need 10 people, or is 2 people going to be okay, right? So third one, and we'll move on from here, but just totally different realm, right? A government agency came to us looking for computer vision solutions. We've got a ton of data. We got people looking at these videos. Can we not have people watch all these videos themselves, right? Is there a better way to do this? Of course, right? Data science, machine learning is the world for this. So we built, this was a fun one because I think we built the whole product in a month or 2, but it's just object detection and tracking. Layered on top of that, there's behavioral pattern recognition from the tracking and object detection data. And then layered on top of that, it's anomaly detection. And we've got more features in there now, like similarities between videos and scenarios. Tons of cool things, which really just gave this government agency the ability to say, look, I don't need to hire 100 more people to watch videos all day. I can take my great people and have them scale now, right, with a tool like this. So data science solves all kinds of problems. At the end of the day, the goal here is ROI for your company, right? And whatever that use case may be for your company. So kind of broad perspective, there's a lot of stuff going on in data science, right? A lot of ways you can add value. So how do you do this, right? Say you haven't taken that first step, and to be fair, you're not alone. There's a lot of companies who have had hesitation. They've seen the buzz, but there's always this question: is it really going to apply to me? Am I going to see the ROI that everybody talks about? There's you have to manage some risk, right? The key here, though, is recognizing what skills you need for your current situation. What stage are you in this data science process, right? And again, this applies to businesses and also people entering the field, right? If you're applying to a startup who's starting to look at data science, right, there are certain skills that'll help them more than others. So how do we have a conversation about something like that, right? To kind of set up a framework, I've taken some opinions, some liberties here to say, okay, let's break down the critical skills of a data science team into some dimensions, right? So we'll say we'll have our soft skills on the left and our hard on the right. So let's talk a little bit about it. I've picked 11 here, just from my own experience and what I've seen over the years. Someone else may come up with some different dimensions, that's okay. But I think this does tell the story of progression and what you need pretty well. So let's walk through them and see, what do I really mean about each of these skill dimensions? So communication. You hire anybody in any company, communication is important. It's part of the interview process. You're looking for this. In data science, it's special. The communication expectation here is different because it's not just a technical person talking to a technical person all day. It's technical people talking to non-technical people and back and forth, and just this crossing layers aspect, which is extra challenging. And this is something data scientists have to excel at to be successful in business. Next one, storytelling. If you're in like a POC phase, and you have a data scientist who is struggling to tell the story, you're never going to move out of POC. No one's going to really understand the value that you're adding if you can't wrap it up in a good story. And this is why storytelling is really just one of those critical pieces of a data science team. Collaboration, again, this is another one where, yeah, everybody needs to collaborate, but data scientists have to collaborate outside of their technical world. They have to collaborate with people who don't understand what a neural network is at all, right? You've got to build one, but you got to explain it to somebody who doesn't know what it is and doesn't want to be taught what it is, right? So collaboration is huge here. Business acumen, I think, is one of the often overlooked pieces here in data science teams. You need people who really understand the big picture. You know, if you can go build a cool model to optimize where people sit in the office, great. What's ROI here, right? What's at the end of the day, how much did you really help your business? It might be cool, it might be neat. You might have, you know, now your friend is sitting next to you, that's fun. But, you know, at the end of the day, what are we getting out of this, right? And that perspective is critical in data science teams, of being able to prioritize adding features to products, or what product do we pursue next? And then, of course, leadership. This is important for any team, not just data science. And I don't know that there's a special data science component to that one, but it's critical here. So hard skills, run through those quickly. Problem solving, right? This is, I'd say, if you had to pick one trait of a data scientist, that is the key trait, it's problem solving. It's not necessarily machine learning, deep learning, neural nets, anything. It's the ability to talk to somebody, understand their challenges and their troubles, and turn this into a problem statement, right? And turn this into a math problem or an algorithm, and something that you can have a solution for. Next, I'd go with software development, right? If you look up blog posts or what is data science, you're going to see tons of things like Jupyter notebooks. Cool, those are great for exploration. At some point, you're going to need software development skills. You got to pull it out of the Jupyter notebook and you got to put it into prod. And that's where these skills are going to, you know, really shine. Data wrangling, similar. You're going to have these hard skills of not just being handed an Excel file and working on it, right? You've got to have the kind of people that can go out on the internet, scrape some data, clean it up, put it into some databases for the rest of the team, transform it as needed, right? Data wrangling skills go a really long way in data science teams. Advanced mathematics, maybe I'm a little biased here, but I'm going to say maybe not. I come from a math background heavily, but there's, like I mentioned earlier, there's a lot of data science use cases out there where you don't need machine learning, right? If you have the right math coming in, you can solve a problem mathematically, and that's where these come in. But also, things like machine learning, deep learning, if you really want to understand how those algorithms work and really improve on problems like that, you're going to have the advanced mathematics background there. And obviously statistics, let's not forget that. Data scientists are often called statisticians, and I would call that some at least moderately advanced math, depending on what stats you're using. And then the last two, machine learning, deep learning. Yes, deep learning I would call a subset of machine learning, but I would separate them in a list like this because you would not invest in them at the same time within your team. Okay, so quick rundown. These are the dimensions. I hope they make some sense. Let's say, how are we going to have this chat, right? We've got the dimensions. What's a framework for a discussion like this? So let's take a look at just a radar plot for all those skills to visualize a data scientist, right? So we see on the right, these are all the hard skills that we talked about a second ago. And then on the left, we have the soft skills. And this radar plot or spider chart, whatever you like to call it, right? This would represent a team, right? A team's capability. So if you have a whole bunch of people on your team and they all kind of average out to be really good generalists when they work together, then yeah, you'd be about a 3 all around. And that's what we're looking at here, a team being plotted in all these dimensions. Something I'd like to reiterate here is, so people don't misinterpret, is that we're talking about data scientists, right? So if I'm saying machine learning skills within a data science team, if you are about 2.5 on the machine learning scale in a data science team, then you are average data scientist, you're doing well, right? This isn't average, I read a blog post, I know what it is. That's not 2.5. If you've never dealt with any of this stuff, you're probably down towards 0. This is in the world of data scientists, where do you fall on a normal distribution in this skill set? So if you hire somebody with a 1 or a 2, they're still capable in this field. They just aren't, you know, world leading experts like a level 5 might be. Okay, so I think we have a framework. So let's talk about this. Different phases need different things, right? If you're at this phase 1 testing the waters kind of idea, we want to explore, is data science going to help my company with my problems, right? The priority here is demonstrating value to the business. The people you're looking for in this phase, I like to call them the data science businessmen, right? These are the people that they bring these skills to the table, the hard skills like machine learning and math and data wrangling and software development, but they lean heavily on the soft skills. And this is a critical aspect of these early stages, right? You're interfacing with the business frequently, trying to identify what are the problems we should solve that are worth it. And once you've built POCs, you've got to get the stakeholders on board, right? You've got to explain to them in a way they understand why this is useful. So just some key points, you know, what are the high points of someone like this, right? Problem solving is critical here, right? You've got to have somebody who can go have, you know, back-to-back meetings with a bunch of business stakeholders all over the company and understand their problems and how to solve them, right? Now, all kinds of algorithms come into play here, but problem solving is the key point. Communication. If you have an overly analytic person, they're going to struggle to manage these business relationships, right? They're going to have a difficult time explaining concepts and having, you know, meaningful conversations with stakeholders. So communication is critical in these early stages. Storytelling, same reasons I mentioned earlier. If you have built something and you've got a model 95% accurate and people are hung up on that 5%, right? How do you tell this story in a way that people understand the value that's being brought to the table? And then finally, business acumen. I think this is the most critical stage of business acumen, is really identifying the right problem to solve. This is common data science anywhere you go, really picking the right problem to solve at the right time. Yeah, so I think that this is a pretty good example of the team skill. Whether it's 1 person, 2 person, or 3 is up to you, right? Your level of investment, but the important part is to try to cover these skills at this level with the data science businessman. So let's look at phase 2. Before I dive into this, let's explain what the chart looks different now, right? What we're seeing now, we have two overlays here. This is the blue is what your team looked like exiting phase 1. Phase 2 is represented by the new color overlaid on top, which is saying these are if you're going to go hire new people, this is probably what they should look like. But at the end of the day, what you really need to do is make sure you cover the things that are exceeding your old skill levels, right? So in this case, if you're looking at productizing you had your phase 1, your exploration phase, you want to productize something, right? People think this looks great. You want to put it in their hands so they can use it. This is where you bring in the data science engineers, not to be confused with the data engineers, but these are data scientists with some additional skills in the engineering world, right? So software and data engineering. These are the people that are really going to help you productize what you have. This is all kinds of things like managing your data consistently in prod, as well as fault tolerance and long-term maintainability of your models, right? Data science in prod is different than other tools in prod. The data, as you're constantly bringing in new data, there's chance that your data changes. There's chances that your models stop performing as they used to. And these are all new things you have to start tracking in production in data science. So this is where the data science engineers really come in. And I do have an extra point up here in problem solving. It's not a 5, it's okay. It's pretty high though. And just to throw this out there, if you're productizing your first data science tool, being scrappy is key, right? It's okay if you're not best practices everywhere, all over the board, because that's going to slow you down getting anything done. These data science engineers are often going to be really scrappy people. They don't know the perfect answer. They don't know all the best practices everywhere, but they will get it into prod. They will get something giving answers to your users reliably. Right? So yeah, I think that summarizes data science engineer. And so you've gone through phase 1 and 2, right? You've done some exploration, you've picked some problems, people got buy-in, right? And then you've moved on to the next step of say, okay, let's put it in everybody's hands as a tool they can reliably use. So the next stage from here is you've had some success. Let's move out, right? Let's fan out. Let's find the other problems that we can be addressing as well. What other ways can we help? And this is where you start looking at bringing in data science leads, right? For each one of these efforts, you're going to need somebody who can guide. And the skill set here is going to be similar to the first stage, but with a little more experience, right? Often in the first stage, I'll go back just briefly, the data science businessman, heavy on the soft skills, these people can come internally. You don't necessarily have to hire these people from the get-go. They're often your rock star analyst that's been around for a while, right? They already have a good perspective on a lot of this. Maybe you bring somebody in to help them out, but these can often come internally. The data science leads, you bring in external power, right? You bring in some more guns in the machine learning and math kind of expertise area, a little bit more deep learning than you probably already have. These are rock star problem solvers again, and they have the leadership capabilities needed to lead a team of data scientists. And just a quick note on what that means. Leading a team of data scientists, I've often heard people call it managing data scientists or leading them is like herding cats. They're not wrong. Data scientists are highly technical people. They know it. They know they're smart, right? So you can have personality conflicts and clashes within these teams. That's part of the process. It's okay. Those things, you handle them professionally, they work out. But a key component of a data science leader, right, is someone who's bringing enough technical merit to the team to be seen by the other members as a leader. If you bring in someone who's super business acumen and very low on the technical side, your data scientists are going to be very hesitant to follow a person like this, right? So the leadership skills can't be alone. They have to come with the expertise in this data science lead role. Right, so with the data science leads, you go, you find new problems, you talk to more stakeholders, figure out what else can we solve, and you bring new problems to the table to start solving them. So once you've got some more MVPs out, you're ready to productize, you probably don't want to follow the same pattern as your first one. This is where it's time to start bringing in the data science developers. So these are people who have much more familiarity with best practices across the board, right? So these are people who they live and breathe in the code. They're probably not in Jupyter notebooks almost ever. They're building frameworks themselves. This is also a really good time to bring in some expertise in machine learning, because building frameworks and productizing machine learning tools, like we said, is a unique challenge, separate from software on its own. So yeah, these people tend to have great collaboration skills, because if you're going to define a pattern to productize your data science work within your teams, you need to understand what they're working with. You need to be able to go work with all the teams, all their MVPs, understand what their challenges are, and come up with a pattern that works for everybody, and it's something relatively smooth. And ML and prod, there's all kinds of things you can look into here, like ML ops, or if you've heard of things like ML flow, there's lots of tracking of machine learning products that is just going to be new to your team, and it's something you need. It'll be nice to bring in experts if you can, but to be fair, things like ML ops and ML flow and all this other stuff, you can probably skill up your existing team to an extent, right? So it doesn't, these overlays don't always mean go hire new people every time. Sometimes it just means invest in growing your own team. And yeah, data and software prod standards are going to be critical to really define a pattern of what it means to productize the data science work that you've done. Okay, so phase 5, this is kind of the last stage, right? When you make it here, you're kind of on the bleeding edge of what's going on in the world of AI and machine learning. You've productized many things. You have prod patterns down. You've got very good people. If you look how big the blue's gotten, right? Your soft skills are mostly covered. The only thing really left in your hard skills to cover would be advanced math, which is I'm a big fan of bringing in at least one PhD statistician purely as a statistician to your team. This is where lots of advanced math will come in really handy, just in stats, but also if you're on the bleeding edge of research and you're trying to change the architecture of the cool some cool transformer model, you want to add something to it and change something up, it's going to be pretty critical to understand the math. And this is where you finally start ramping up on the deep learning here. Now, I'll admit there are some use cases where deep learning can come in earlier. You'll have to play that one by ear, depending on the problem you're solving. But for most cases, to really get the value out of data science quickly, you kind of leave this as the extra value you can pull out in the end, right? I also like to put these as kind of rock stars in the software and data realm as well. This is where you start looking at building your own frameworks in-house, right? If you're doing a lot of forecasting, maybe like Facebook Profit, right? They had a lot of forecasting going on. They built their own forecasting framework, their own tool to do this. And this is where you start looking at doing these for your own internal teams as well, to really build out, the best way for us. Okay, so we've done it. At this point, you've filled out your spider graph, your radar chart. You're basically looking like a circle. You've got all the skills you need. You're heavy on the problem solving, maybe a little lower on business acumen than a real, purely business person would have been. But you can cover all your bases in the data science world, work well with the business, and deliver, great data science, AI, ML, deep learning solutions. The key here, be well-rounded. And to accomplish being well-rounded is to have more than one person be well-rounded. It's to have a bunch of people on a team contributing to this concept of a well-rounded team, not well-rounded, smoothed out individuals. Okay, so that kind of wraps it up, the summary of how to jump in and how to climb the ladder. Just thanks everybody who's come to hear what I had to say and listen to us. We can start looking at questions now.
Awesome. Thanks so much for all of that awesome content, Cori. If anyone has any questions, please go ahead and add that to the Q&A section right now. And I'll just give it a couple minutes and we'll see if anything comes through. Oh, it looks like we actually had one question come in through the chat. This says, what industries are undervaluing data science?
Industries undervaluing data science. Good question. I would say most places are probably undervaluing until they have taken that first step to really see what can we get here, right? So like we saw on the Mackenzie Plot, let me see if I can pull this back up. Maybe I shouldn't have closed it already. Okay, I don't even know if I'm still sharing. So let me we'll just talk. Right, so from the Mackenzie Plot, right? Most of these industries have tons of capability here. What it comes down to is how resistant are people to adopting it. And they're not wrong, right? There's a lot of people who have been in the business for decades, right? So let's take something like, I don't know, agriculture, right? Agriculture, they've been solving their problems for decades. Do they really need some, PhD scientist to come in and redefine how they approach all their problems in a way that they don't understand anymore? There's hesitation there, and they're not wrong to be hesitant. And this is why we really got to lean on the soft skills here, right? There are people who are going to be uncomfortable for a little while, and there's also plenty of buzz articles out there trying to say AI is going to take everybody's jobs. We're not there, guys. AI is developing, but it's definitely not laying everybody off yet. So it's the way data science tends to help people is to make them more efficient, right? It tends to say, I'll empower somebody. There's someone already doing this job. I'm going to give them a tool to do their job, the same job they're doing, but to do it just a little bit better. So yeah, I don't think I can point out a specific industry that is missing the data science wave, but I'd say across all industries, except maybe just tech. Tech is probably embracing it pretty well, but most other industries, they have their hesitations.
Awesome. And Cori, we had another question come in. Okay, this says, for a general enterprise, for example, manufacturing firm, perhaps 500 plus, wholesale or direct to consumer business model, should the data science team exist in the business or IT? What's best in terms of longevity, success from your experience?
I love that people are asking these kind of questions. So I've seen both. I've seen both be successful, but I have a strong opinion that data science should be separated from the business use specifically. I think data scientists work much better as a whole data science team, where they kind of outsource to the business. Business comes to the data science team to say, hey, we have a problem, can you help? The reason I say this is the longevity of data science teams is heavily dependent on knowledge transfer and growing team members. So if you think back to the spider graphs and everything, realistically, you're going to hire people with strengths and weaknesses, right? So if you have a computer vision strength on your team and you have a mathematical optimization expert on the team, if you silo them to different parts of your business, they're not learning from each other. But if you keep them in a greater data science team under IT, right, then these people are able to grow each other. And this is going to be critical to maintaining all your projects long term and just growing as a team in general.
Excellent. We had another question come in from Morgan asking if your slides are available. And Morgan, we will be sending out an email after this with the recording of the whole presentation, and everything will be available to you. So yes, everyone keep an eye out for that. We had another question that says, has the pandemic made data science even more desirable?
I think it has. So the interesting thing here is, I'm going to be totally honest with you guys. So data science depends on data. Do we have data from previous pandemics? Not really, right? So COVID came in as this first instance where we're all learning as it comes in. That being said, we have some data on a pandemic now. So we have a whole lot of new information for data scientists to use about how did your supply chain handle this, right? And we can learn a whole lot with data science and solve future problems by learning from what did happen in COVID. So it is a very forward-looking thing. I can't name anyone off the top of my head who had a forecasting model that handled COVID perfectly. It's unrealistic because their forecasting models weren't trained on pandemic data. That being said, now that we've seen this strange event, we can understand it for the future. And I would say the good forecasting models were able to pick up on trends earlier than old school forecasting models. If you're just using something purely statistical like ARIMA models, COVID just blew you out of the water. It sucks, it hurt, right? This is time to start looking at external features in your forecasts, right? That's just one simple example of where COVID and data science are really going to be hand in hand. If you're using external features, you probably picked up on it a whole lot faster. If you're not, probably you felt that one.
And Cori, we had another question come in, and it says, do you have any advice for demonstrating ROI for data science efforts to leadership that might not believe in the benefits?
Yeah, so this is where the storytelling really comes in, and this is, let's be realistic again, right? Data scientists are really technical analytic people, so not all of them are going to be the greatest storytellers you have, but you will find some, right? There are going to be some who have that kind of specialization where they can do that. And this really comes down to putting it into their perspective, right? And to be fair, use blue on your plots. Don't use red, things like this, right? But it comes down to storytelling and understanding their perspective and showing them that, here's what you did before, right? And here's what you could have, right? If we used this POC model that we've been developing, here's the difference it would make. If you can in any way quantify it to dollars, that speaks to these types of people better than anything else. That's challenging sometimes. And, data scientists, often very technical people, we're going to come up with all these, we tried to quantify the dollars, but it's wrong here, here, and here. Yeah, sometimes you have to make some assumptions to get a calculation out the door, right? And I think those are the critical components. So storytelling, turn it into dollars in some way if you can. And understand the perspective of the person you're speaking to.
Excellent. And we had another question come in, so let me read that one out loud. In terms of data science initiatives, sponsorship, and support, are we in an era now where the CEO, board, senior leadership orgs should be demanding new capabilities and research and development, or is bottom-up sponsorship approach effective?
Neat perspective there. So in my experience, you need a little bit of both. Bottom up is great at the beginning, right? Bottom up is saying, look, we've got problems. I think we can solve them better. Let me just take the initiative, bring the people in and show that this is possible. But long term, if you don't have the top down directive to say, we're going to leverage data science and machine learning to drive our business decisions, then you're going to have people who refuse to adopt. And those are going to be giant barriers in the process. So I hate to say it, but the answer is you need a little bit of both. But if you had to pick a starting point, start at the bottom. You can use the bottom and the POCs to bring in the top level leadership and get them on board afterwards. But yeah, at the end of the day, without the direction from the C-level, C-suite people, right? If they're not saying everyone in my company must use this tool developed by the data science team. Like if you're making these decisions, you have to do it in this tool. Well, then you're gonna have people who just don't want to do it, and we're sorry about that. Yeah, you'll have people who don't want to adopt for whatever number of reasons, right? So once you get everybody on board, it's much better to get a solution that works for everybody. So you do need a combination of the two.
Awesome. That was hilarious, Cori. I love it.
Forgot to close the door.
I think we have all the questions answered, and I'm just going to wrap up really quick. If you have any additional questions that you want to ask Cori or just ask Blueprint in general, you can email info@bpcs.com. You can also connect with Cori on LinkedIn, and be sure to be following us on our socials on LinkedIn, Facebook, Twitter, and Instagram. We'll be posting any new upcoming webinars. So make sure you keep an eye out for that. And we'll also be posting the recording on our socials as well. So thanks again, everyone, for joining. And I'm also going to be adding to the chat a really, really cool new tool that we have come up with. And Cori had a great deal to do with this as well. It is an analytics tool. And so if you have 10 minutes after this, hop onto that, and it can really bring some great insights to you and your company as well. It's a free tool, so just give that a go. But thank you everyone so much for joining, and I'm going to add that in the chat now, but enjoy the rest of your day.